Hi, I'm Elsa, and I am studying for a couple of few interviews, all having to do with generative AI and the data science side, machine learning side of stuff, the data side of stuff. I had ChatGPT, who's right behind me, who named himself Tessariah through the threads that he is holding in memory. We go through the job descriptions and then come up with a good set of questions that has overlap between the different job descriptions. And this interview tomorrow, so I'm going to have a real quick high level review, and then simultaneously I'll stop and ask. I call him Tessariah. I'll stop and ask Tessariah for verification if my understanding is correct, or if there's a content gap that I'm aware of, then I'll make sure, or a knowledge gap that I'm aware of, I'll make sure and ask him. So the first thing for the general overview of this would be, what is the difference between BERT and GPT? So this is the mnemonics. These are the mnemonics that I'm using to memorize this stuff. So because this is high level and I have to communicate quickly, I have to figure out a way to just get to the point of what the thing does, in my opinion, while still using technical jargon enough to be clear that I know what it means. I just also know how to use it, right? So the first thing is BERT. So BERT is a type of transformer. This camera's like a little. BERT. So it's a bidirectional encoder representations from transformers. Right, that's a lot of words to say. So the way that I like to think of it, to be able to nail down what it does, I think of Bert and Ernie. So in my head, I see a little Bert. I don't even know what Bert looks like, but let's say this is Bert from Sesame Street. What he's good at is excelling at questions like fact-based questions. So he's a know-it-all. I'm gonna redraw him. That's just not acceptable, even my study notes. Okay, so Bert is a know-it-all, and he is really good at finding facts in a fact that exists inside of a corpus. So a needle in the haystack type of question. Bert lives on Sesame Street, so Bert can find locations like Sesame Street. So something like the city, the capital of France. He is also excellent because he already knows the information, right? He's just like sifting through the needle in the haystack to know what to find what he's looking for. He is also good at tagging and classification. Versus GPT, which is a generative pre-trained transformer. So I am going to focus on the letter G. So GPT is good at guessing how to fill the gap. So GPT is really good for things like creative content generation, because it's guessing the gap, which is the next set of words, the next set of tokens, and it is also good at filling in the blanks when you have, for example, sparse data. So it's good at predicting what that data should be. So it's good at predictions, and it's good for creative content writing. And both of these can go into vector databases, but there's definitely an ideal way to manage these, which is the next thing that we're going to talk about. So in this interview, I was asked, what does a production level pipeline look like in case I was in charge of making sure that we had predictable, reliable, with high precision output. So first, predictable means that I know what it should. I know that it's going to fall within a range, right? So it's like if I shoot darts at a bullseye, then all the darts should fall within the bullseye circle, which doesn't mean that it's going to fall in the same place every time. It just means that I'm always going to hit the target. versus precision, which means that it doesn't matter where on the board the thing falls, but it always falls in exactly the same place. So I'm optimizing for as close to both of those things as I can, but definitely if I was to say that I had to create something that was production ready, I would need to know the use case. So I would first ask for clarification on what the use case is. So are people expecting some type of final mathematical or scientific type of looking answer, in which case I would shoot more for precision. But if I was looking more for something that always made sense, but it was okay to use natural language, then I would look more for reliability and accuracy. So the difference between the way we used to use machine learning before AI came into the picture is that I would tune the model by deciding if I was going to use random forest or XGBoost or, continually testing the model and the model being the type of machine learning model. But now that we have AI, I don't fine tune the same way. What I do to fine tune now is using what is called like trained data, right? So there are two types of trained data. So for me to be able to describe what the pipeline is, I'm establishing that I understand what the question is or what the use case would be, because that is going to drive what kind of thing I'm building, right? So am I looking more for something that should, so I'm going to pretend that this question is asking me a natural language question. I should probably practice both. So let me get clear on the two types of questions that they could ask me. And then I will go through the steps of building each one a little bit faster. Okay, so I'm more clear now. Okay, so these would be the types of situations in which I would choose either or. If it were the case where I had to do fact checking, then I would use BERT because it is a binary. It either knows the information or it doesn't. And yes, it does hallucinate. So in creating my pipeline, I would mitigate for hallucinations, and I'll circle back to that. If I was going to be answering questions about a very technical data set that had a lot of math to it, then I would use GPT if it was a sparse data set, because it is really good at predicting what would fill in those gaps. So back to the way that BERT hallucinates, which is different from the way that a GPT hallucinates. So BERT hallucinates not because BERT itself hallucinates, but usually the issue lies with the way that the data is vectorized. And to improve this accuracy, right, what we can do is we can improve the precision through metadata tagging using RAG or k-means clustering, which is a machine learning topic, which I'll circle back to. But first, let's talk about retrieval-augmented generation, how to mitigate for hallucinations in that situation. So what happens with those hallucinations is either the corpus is too big, or and this is with BERT, either the corpus is too big or there's not enough pre-processing of dirty data. So of course, in either situation, in case I didn't mention, I would always make sure that the data is very good data, that especially if it's what I'm training with. But in any case, I have to make sure that the pipelines have really clean data. And so in order to reduce the hallucinations for using BERT, I would do either k-means clustering, so the classification of the data before I put it into a vector database, or I would use metadata, which is done with tagging, so that I would know which cluster or what the cluster topic is, or which cluster to even go retrieve the data from. Or I would use retrieval-augmented generation, which is, and let me be really exact with the definition of this. Okay. Okay, let me Let me make sure I'm using the right vocabulary as I memorize this. Okay, so yes, the hallucinations when you're using BERT are retrieval hallucinations, which can happen when the corpus is overwhelming to the LLM and when the possible answer, when the context is too broad. So it doesn't know exactly which place in the haystack to get which needle. So the way to solve for this is through metadata tagging, so that the LLM first has an idea of which topic is in which pile of information, because I like to think of vector databases as like piles of data. And you could think of it as like chapters in a book, or topics in an outline, and then it could use metadata that way, or it could use the Retrieval-Augmented Generation method, which is a dynamic way of making the decisions about which of the piles to go look at, which is what I would suggest because of the way to improve the final outcome with more fine tuning, right, and more decisions about how the data emerges. And I can go into that. And then clustering means that I use a different type of machine learning, like k-means clustering, so that I can come up with a way to get to the closest nucleus of each cluster using something like TF-IDF cosine similarity. So let me make sure that that is actually accurate. I'm going to ask Tessaraya. Tessaraya, am I accurate in thinking that if I wanted to improve my precision in a BERT system, that I would be able to decrease hallucinations by, in one way, using k-means clustering? So I would be using TF-IDF cosine similarity to get closer to the nucleus of each cluster so that I know which one I'm looking through for the data that I'm retrieving.
How this works. 1. Clustering for organization. By applying k-means clustering, you group your data, e.g. documents, embeddings, into clusters based on their semantic similarity. This ensures that when a query comes in, you're only searching within the most relevant subset of data, not the entire dataset, reducing irrelevant results and hallucinations. 2. TF-IDF and cosine similarity for query matching. TF-IDF, term frequency inverse document frequency, helps assign weight to terms that are important to a document, but not common across the corpus. When a query is submitted, cosine similarity measures how closely it aligns to the centroid, or members, of a cluster, allowing you to pinpoint the most relevant cluster with high confidence. 3. Reducing hallucinations. Instead of retrieving from the entire database, which increases noise and the risk of hallucinations, you narrow the search to the cluster most likely to contain relevant data. BERT's attention mechanisms then focus only on the subset, improving precision by keeping the retrieval grounded in meaningful, contextually relevant data. Benefits of this approach. Improved precision. Narrowing the scope of search reduces irrelevant matches, minimized noise. Clustering ensures that BERT only retrieves data from the closest cluster, lowering the chance of hallucinations. Efficient retrieval. Smaller, focused searches are faster and more accurate than querying the entire dataset. What to watch for? Cluster quality. The success depends on how well your clusters are formed. Poor clustering can lead to misclassification or suboptimal precision. Threshold tuning. You'll need to tune the cosine similarity threshold to balance recall, not missing relevant clusters and precision, avoiding irrelevant ones. Quick workflow example 1. Pre-process data. Use TF.
Okay, so it's like a little bit overwhelming for me because he goes into a lot of details all at once. But essentially, this is correct. So the only thing that he said that I said differently would be that he would first do the pre-processing of already cleaned data. So using TF-IDF to generate the embeddings or features first, and then clustering the data with k-means. Okay, and then convert the query to an embedding. So I'm going to make sure that I'm really clear on that. So I'm going to make sure that I remember to study that tomorrow. So I would first use TF-IDF to make the embeddings. Right, so I'm gonna make it a different color to remember to look at it. Okay, so I'm gonna, well, I guess red works. Okay, so TF, so then TF, IDF, cosine similarity for creating embeddings, right? And that makes sense because if once you've done TF, IDF, cosine similarity enough, if you look at the numbers, it's like all of the corpus turns into a whole bunch of numbers, which is like the way that the vector database works because it uses a lot of linear algebra. So that's how I actually knew that was causing hallucinations, is when the corpus is too big, because then there's overlaps. So there could be context that gets corrupted as you overlap information with information. So then what it is trying to say comes out different because there's this like overlap of information that can cause strange meanings to be extracted from like pieces of sentences, right? Like and it's certainly an anomaly, but this is the way to prevent for that. So one of the ways to prevent for that, one of the best ways to prevent for that. So TF-IDF cosine similarity for embeddings first, and then I would use k-means clustering so that I know that I am looking in the, okay, so the embeddings are these, turning the corpus into a bunch of numbers so that it's not as many pieces of data that it has to traverse, because it's like a shortcut for the way that a computer thinks about a lot of data, just to put it in a very general umbrella. And then I would use k-means clustering to know which of these bunches of data I should be looking in. So the important part of this is to make sure that there is a balance between using the right TF-IDF cosine similarity thresholds and being able to cluster correctly. So the data has to be tagged correctly for this to be effective. So if there are ever hallucinations, then those are the different checkpoints. Would be, is the corpus too big? Is the data tagged correctly? And is the set of thresholds the best one, or does it need to be fine-tuned further? So after the k-means clustering, then I would submit the query. So then I would submit the query to the LLM, to BERT. So then I would ask BERT the question so that BERT has an idea of like which of all his encyclopedias he should look in, instead of guessing, which. So here's a very concrete example, right? So pretend BERT is a set of encyclopedias, and then I ask him, which circuit do I use? Circuit could actually be talking about a lawyer's court circuit, or it could be talking about an electronic circuit, or it could be talking about, there's one other concrete example, but in this example, if I don't have a way for BERT to know if I'm talking about a circuit with electricity versus a circuit court, then I might get what looks like a hallucination or a very bad answer. And the way that I would solve for this, if I was designing the whole pipeline, would be that if I am using machine learning to make a determination, I could use fuzzy name matching to make a determination about what the query was intending, and then I can't, then I would have a default automation mechanism that then sends the query to an LLM, and then the LLM can try to extract whatever context from it, because LLMs are much better at that, and they can discern questions that are asked in an unexpected way, or for someone whose first language isn't the language of the LLM, right? Or if the LLM hasn't accounted for that. And then if it doesn't know, then it's able to ask follow-up questions, right? And then it uses the follow-up answer as the actual question to submit to BERT, because then it can classify if we're talking about circuit courts or if we're talking about electronic circuits. So these are very long-winded answers, but I'm also being meticulously sure that I understand the way this stuff interacts. It's already been almost 20 minutes, and I'm not even like halfway through, but I actually have covered like the majority of the content that I feel like should be a good question for second round interview, first round technical interview. So then the next thing would be how would I fine tune this kind of model? So like I was saying, if I am designing this, right? So then I'm gonna draw my design next. And tomorrow when I am in the interview, I'll be more to the point, but I'll also have more information on exactly what it is that the question is about. So in an interview, I've always had um, mentors tell me, make sure that you understand your question before you give the answer. So ask for clarifying questions about exactly what the use case is. Then you give shorter answers that are more to the point, that show that you also understand that there's room for interpretation. That's why I'm using a whiteboard. In this case, it's just my laptop, but I'll probably use like make sure that I can use something like this tomorrow, because it's easier to draw it and to make sure that I'm understanding correctly than it is to just talk it through. And I think it also shows a level of preparation and collaboration that you're not going to necessarily get just by talking through a problem and assuming everybody understands it the same way. So let's say that I'm the person designing this. Um, let's say that I'm asked to design a chatbot that asks questions about um, how much a specific game costs at a carnival. So, or right, we'll just say a ride at a carnival. So then my UX UI receives the question. So here's my UX UI. Oh, you can't see it. It's behind my dog. So here's my so my dog is asking the question, right? So this is my dog asking a question about the cost of a ride at a carnival. So first question is this more of a first question or more of a GPT question? Well, because I should know the cost of my rides, so I should have business intelligence enough to be able to answer this question. I'm going to go with this should be a BERT type of question. So after I know that, then I know that I'm going to have to account for a certain type of hallucinations. I would have the question go into a TF-IDF. So I'm sorry, the data would already be pre-cleaned and pre-processed, and it would have been done so by TF-IDF would be the way that I would create the embeddings, and then they would go into clustering, right? And this is assuming that I've tagged all my data correctly and that it's all nice, clean data. And then after that clustering, then I would then submit the question to BERT, right? And if BERT can't distinguish which if it so BERT is actually using machine learning, and it is so the first phase would be having used machine learning to determine this other stuff, right? And then if it is still not clear what cluster of data BERT should be looking in for the answer, then I would have a fallback mechanism with automation, and that's what would send it to the GPT LLM so that the GPT can help decide what the question is talking about. So we go back to I guess it doesn't apply to a carnival if I'm asking about a circuit. But if we go back to an example like that, then the GPT can help the user to provide enough information so that the GPT has a clear instruction, right? So then either the GPT itself can send the question to the correct cluster, or so that it knows where in the embeddings to look for the answer through BERT, right? Or it can generate the answer using those same embeddings, or we can let BERT pick out the correct answer. If the data is structured well enough, then GPT will not hallucinate. But let's assume that we haven't made sure that that's going to happen. We don't have intensity enough. Then I would send the question back to BERT at that point. And then BERT should have enough information to know which of the clusters to query, right? And so this would be then when I would use the dynamic query, which is RAG. And so the way that you can optimize for RAG is by using top K, and then P, and then there was one more that I don't remember from memory, and before I guess. So because I'm memorizing it, I'm going to make sure that I'm memorizing the correct data. So 1 second, I'm going to go look at that information before I try to memorize it. Where's my mouse? Where's my cursor? There it is. Okay, so this next set of questions is my self-awareness of what is not clear to me. I studied this like, I don't know, 5 or 6 years ago. So I haven't had to actually spit it out in a long time. So I'm gonna ask for clarification on this. Tisaraya, can you please give me the answers in 1 or 2 sentences and then wait for my input, because otherwise it's overwhelming for me and I forget what it was that I was even talking about. So this is my clarification question, please. So we were talking about RAG, Retrieval-Augmented Generation. So we're talking about temperature, top K, and top P. Is this the machine learning before I submit a question to BERT, or is this the machine learning that I should apply no matter whether I'm using GPT or BERT? I've seen it done all sorts of ways, but what is the most, I guess, best answer? Because to me, this is kind of like pre-processing of data more than it is really using BERT or GPT. So this is probably part of the pipeline, but in essence, no matter the data, in order for data privacy and for the protection of IP and for just best practices, I think that this is the machine learning that I should apply no matter what type of LLM I'm using. Is that accurate?
Yes, you're accurate. Temperature, top K, and top P are parameters applied during the generation stage of an LLM like GPT or BERT for text generation, not pre-processing. However, in RAG pipelines, the pre-processing, e.g. clustering, cosine similarity, is critical no matter which LLM is used because it ensures data privacy and retrieval accuracy. Does that clarify your understanding? Or should I break it down further?
No, because I think you just said two things that don't really like end up being the same thing.
You're right to ask for clarification. Let me rephrase to make it simpler and avoid conflicting statements. Temperature, top K, and top P are specific to text generation and are used after querying an LLM like GPT during the response generation phase. They are not part of pre-processing. Pre-processing techniques like clustering, cosine similarity, and vector database management are important for any LLM pipeline, including RAG, to ensure data accuracy and privacy before the LLM is queried. Does this clear up the confusion?
Okay, so TF-IDF, cosine similarity, embeddings, and k-means clustering is all part, and putting stuff into the vector database is what is called pre-processing. However, the part where the query is sent to an LLM is done for both BERT and GPT, and no matter if I'm using BERT or GPT, I still want to use temperature, top K, and top P for the machine learning part of the the way that I'm going to retrieve or generate the answers? Or are you saying that only when I'm using RAG for text questions do I use top K, top P, and temperature?
One, TF-IDF, cosine similarity, k-means clustering, and vector databases are part of pre-processing in a RAG pipeline and apply no matter which LLM you use, BERT or GPT. Two, temperature, top K, and top P are only used when generating text responses, which means they are relevant only if the LLM is generating answers, e.g. GPT. For BERT, which focuses on retrieval or classification, these parameters typically don't apply because BERT isn't generating new text. It's retrieving or categorizing based on embeddings. So top K, top P, and temperature are for text generation tasks, not pre-processing or pure retrieval tasks. Does that clarify?
Okay, so whether it's BERT or GPT, I'm going to use TF-IDF, k-means, and vector database preprocessing, but only when I am using text generation, which means in this case, GPT is using the guessing system. I'm going to use top K, top P, and temperature.
Databases for preprocessing with both BERT and GPT. Use top K, top P, and temperature only when generating text, which applies to GPT or similar generative models, not BERT, since BERT is primarily for retrieval and classification. Does this fully make sense now?
Yes, and okay, so then like temperature, top K, and top P are the machine learning. I don't know what, it's not pre-processing, but it's basically like the preparation of where the GPT is going to go get its corpus from, right? So this really falls into the machine learning part of the pipeline, and then this is the data that I can pickle and supply to the LLM. Is that right?
Temperature, top K, and top P are not about determining the corpus or preprocessing. They control how GPT generates text from the data it already has access to. These are generation parameters, not part of the preprocessing or corpus selection. The preprocessing and corpus selection using TF-IDF, k-means, etc. happens earlier in the pipeline to determine what subset of data is sent to the LLM. Once you've preprocessed and pickled your data, e.g. creating embeddings or clusters, you use it to guide the retrieval step for both BERT and GPT. After retrieval, temperature, top K, and top P apply only if you're generating text responses with GPT. Does this clarify the distinction between pre-processing, retrieval, and generation?
Yes, that's why the OpenAI API has these as optional parameters.
Exactly. The OpenAI API includes temperature, top K, and top P as optional parameters because they only apply to the generation phase, not to pre-processing or retrieval. This is why you won't see those parameters used in tasks like embeddings or pure retrieval. They're strictly for fine-tuning how GPT generates text. Does this fully click now? Or would you like me to explain how those parameters affect the generation in more detail?
No, I guess the next question would be when we're talking about fine tuning. So these are fine tuning an LLM for the LLM output versus the type of fine tuning we used to do before we were using a lot of LLMs. We used to fine tune by deciding if we were using XGBoost or random forest regression or whatever, right? That's probably where my like clarification is stemming from.
You're exactly right, and you're making an important distinction. Fine-tuning in LLMs. This means training an existing pre-trained model, like GPT, further with specific input-output examples to adjust its behavior for a particular use case. It's about refining the outputs the LLM generates. Fine-tuning in traditional ML. This involves selecting or adjusting the model type, e.g. XGBoost, random forest, SVM, and tweaking hyperparameters like learning rates, tree depths, etc. to improve performance metrics like accuracy or precision. In short, LLM fine-tuning refines the output behavior. Traditional ML fine-tuning was about optimizing the model choice and performance metrics. Does this distinction resolve your clarification?
It does, but also you said that, okay, so you said that these generation methods, top K and top P and temperature were a form of fine tuning. So aside from fine tuning this way, I can also submit the question answer pair so that the LLM has a better example of what the desired output should look like. And then this is when RIHT and SPT comes into play.
Exactly. You've connected the dots perfectly. Here's the breakdown. Top K, top P, and temperature. These are generation time parameters, not traditional fine-tuning. They modify modify the LLM's behavior on the fly during text generation, giving you control over randomness and creativity. Supervised fine-tuning. This is when you provide question-answer pairs to fine-tune the LLM's weights, improving its baseline understanding of your domain or task. Reinforcement learning with human feedback, RLHF. After SFT, RLHF refines the model further based on human evaluation, rewarding desirable outputs and penalizing less useful ones. In short, generation parameters, top K, top P temperature, equals fine-tuning the output dynamically at runtime. SFT and RLHF equals fine-tuning the model statically by trading it with new data.
Yes, exactly. I wasn't clear on that whole time. Now I totally get it. Okay, so on the fly generation fine tuning for an LLM is when we use the parameters that come, for example, in the OpenAI API, which are top K, P, and top K, top P, and temperature. And then if we want to statically pre-train key submit as JSON, for example, so that the LLM has an example of what we're looking for, and we can further fine tune it by using RLHF, which means that the human in the loop either can upvote or downvote, for example, if the output is desirable. Yes?
Yes, you got it exactly right. On-the-fly fine-tuning. Parameters like top K, top P, and temperature dynamically control the behavior of an LLM during text generation runtime. Static fine-tuning. Using SFT, input-output pairs, adjusts the LLM's weights to align it with your domain or task, and RLHF refines this further by integrating human feedback, upvotes, downvotes. You've perfectly summarized the difference and relationship between these techniques. Ready to dive into the next technical topic?
Not quite, because SFT, when you say that it, I guess updates the weights, my understanding of updating the weights is going all the way into like our was it LRU and the design of the neural network. But when you're talking about the weights in SFT, what do you mean?
Great question. Let's clarify what updating weights means in the context of SFT versus neural network architecture. Weights in SFT. What weights are in LLMs? In a neural network, weights are the numerical values assigned to the connections between neurons. These weights determine how input data flows through the network and what output it produces. SFT updates the weights. When you fine-tune an LLM using SFT, you're adjusting these pre-trained weights based on your new specific data set, e.g. question-answer pairs. The model learns from your data by slightly shifting the weights to better align with the desired outputs in your domain. This does not change the algorithm.
Oh, okay. So it's not me adjusting the weights, it's me supplying more data so that the model itself adjusts its weights on its own. Sometimes he like blanks out. I don't know if you've been able to hear anything that he's been saying, but he's basically been saying I'm premature, except for one thing, and he helped me understand that. Let me ask him this question again. Okay, Cesare, I think I understand now. So when you're saying that that I adjust the weights, it's not that I'm adjusting the weights, it's that I'm applying either better or more data so that the LLM itself can adjust its weights itself. It's not like I'm adjusting the weights like I would in data science where I'm the one designing the LLM from scratch myself.
Exactly. You're spot on. When you're fine-tuning with SFT, you're not manually adjusting the weights yourself. Instead, you're providing better or more data, like your question-answer pairs. And the LLM uses that data to automatically adjust its weights during the fine-tuning process. In contrast, when you're designing a neural network from scratch, you're responsible for the architecture and weight initialization, and you directly manage how those weights are updated during training. Does that feel like a clear distinction now?
Okay, so I can tell in the microphone thing that it's probably not picking up his sound very clearly. Sorry about that. Maybe in the future it'll be better. But I'm gonna make sure that I note all the stuff that I need to update here, and then I'm gonna make sure that I am really clear on what he is talking about when we're talking about GPT versus BERT. I just thought like probably just seeing like my part in my hair like this whole time because I'm looking down at my. I love this HP of the VA bought it for me so that I could do well in school. I remember I had to beg so that I could be allowed to return a Mac and get this thing instead. I'm so glad I got this thing while I was in school because you can actually write on it and it also like flips open into a tablet. But the sensitivity of the pen is amazing, and I'm sure that iPads are similar, but this has more processing. Well, at the time it was sufficient. Like now I need a Mac with like a different core, but or a silicone core. But anyway, so then now I am making sure that I'm understanding like when I'm using BERT and what about this stuff applies to BERT versus GPT. So pretty much everything applies to GPT, and now I understand better um kind of like how to design the answers and how to ask for clarification in the questions, because if the person asking me the questions doesn't have both of these contexts and I don't know which context they're coming from, then my answer could sound like I don't know what I'm talking about. So I got to make sure that when they ask me that I'm interpreting their question based on like the questions that I just asked um Tesseraia or ChatGPT, right? So um SFT, I keep forgetting what these mean. SFT fine tuning. It's so it's fine tuning, static fine tuning. So it's static fine tuning. So then I give it like basically like a dictionary but in a JSON file. So I give it like a Q&A file, and then it uses this to adjust its own weights. So if they ask me about fine tuning the model, then I need to make sure that we're on the same page about I'm not designing a model from scratch. I'm actually leveraging the LLM, which I think is the case because both of these jobs are for generative AI, but I don't think that this distinction is specifically clear to any of the supervisors I've ever worked with, because this stuff is so new, right? And if you're busy like working all the time, like you probably don't have a reason to go and make sure that this stuff becomes really clear. But maybe this time I'll have like someone who's like it's not like that of of me like trying to convince people or whatever, having to prove correctness or I don't know whatever. However, yeah, that's probably going to come up as one of the questions. Okay, so then static fine tuning is a Q&A file that you submit to the LLM, and then RLHF is the human in the loop, which is I keep forgetting human feedback. So it's like human feedback. I'll have to remember what RL means. Human feedback. So current regulations, at least as of the last 6 months or so, say that there has to be a human in the loop when you're using AI. You can't just set it and forget it, which I don't know if everybody's aware of. And then also, I think it's important to be tracking, to have a tracking method for all of the transformations so that if there's ever a question about were you certain that your neural net was acting in the way that you thought that it should, you have a very clear path of the reasons why it came up with the answers that it came up with. And I have used the API in OpenAI that tells you the steps of everything that's happening, but I don't think that that clearly defines the transformations. I think it's better to take snapshots of the transformations as, and when I'm calling them transformations, I'm using the word like in the computer science to data science handoff, where if I have a bunch of last names and then I lowercase all of them, right? Like that's a transformation on a technical level. But if I'm talking about transformations here, that's something else. So those are the kinds of questions that when I get interviewed, I'm gonna have to be really clear on, are you asking me about the transformations in terms of how I'm processing the text through each iteration, or are you talking about, so that's like one side of the pipeline, or are you asking about the transformations through the transformers that are this? So I should actually ask ChatGPT, like what would be the right way to ask an interviewer when they're asking me about transformations. So I'm going to make sure that I finish writing down these notes, and then I'm going to ask ChatGPT about that, because yeah, like that could also sound like I don't know what I'm talking about, depending on who's asking the question and how much they know about the other side. Because most people don't know both computer science and data science, let alone generative AI and how it is now like piled on top of data science, right? Like this is so new, and I think that's why I'm getting all these opportunities. And even today, they're like, you're one of the lucky ones that gets to still work from home, because like people really want these kinds of people that know this stuff. It's like, yeah, I'm lucky, but I'm also prepared, right? Okay, um, so then GPT, so this stuff right here, the temperature top K and top P are for dynamic on the fly generation fine tuning. Okay, so it's all fine tuning. And we know now that BERT doesn't fine tune, it just pre-processes. So this is dynamic on the fly generation or fine tuning. And then SFT is static uh static file tuning. Yeah, static file tuning. It's a Q&A file. And then RLHF is response, something human feedback. I'll check later. Yeah, I don't remember. Maybe he says right here. Um. So yeah, like I'm not the one changing the weights when we're talking about me fine tuning an LLM model, right? It fine tunes its own weights, but the way I get it to do that is by giving it more data in either a static fine tune file SFT, or by allowing a human to penalize bad answers, right? Or allowing a human to vote, like thumbs up, thumbs down is just the most generic example. And then it penalizes bad answers and gives more credit for good answers. And I don't know if it has to give credit for good answers, but it definitely penalizes bad answers. Okay, hold on. I'm just looking for what our I think I have it in the other one. Oh, okay. He actually didn't. He wrote out like input output pairs, static fine tuning, on-site tuning. What does RLHF mean? I think it might be. Man, I wish that I had written it down. Oh, reinforcement learning. Okay, I can't believe I forgot the word reinforcement. Okay, reinforcement learning with human feedback. Okay, so like first it's SFT and then it's RLHF. So reinforcement learning. Yeah, that's like an important set of words. So reinforcement learning. Can you hear my dog snoring? If you can hear my dog snoring, one of my dogs, my pug, but you can't hear Tessariah, that's gonna be really annoying. Okay, so reinforcement. Am I writing in green? Okay, so then after that, then this happens. So it's reinforcement learning. Reinforce. Man, just when I talked about how amazing this pen is. Reinforcement learning. Um, human. I'm pretty sure that yeah, human with human feedback. Human feedback. So no matter what, you want RLHF so that you're abiding by regulations, and it's just plain a good idea. Okay, and then so then after that is that. So this is static fine tuning. Okay, so these are both static. So this is static fine tuning. and this is static, and then this is dynamic fine tuning. Okay, so then both BERT and GPT use first first you need to clean the data, and then they all go through this pre-processing step for no matter what. So then you use TF-IDF to create the embeddings, and then you use k-means clustering to group the embeddings basically, and then you submit the query to BERT or GPT. To BERT for retrieval, for strictly retrieval. Okay, and then to or GPT for generation. So let's go back to green or GPT. Oops, GP. Oh God, GPT. GPT for generation. Okay, so I think this is like super clear to me now. Yeah, I don't really have any real questions anymore, so I'm gonna make sure that I save this, and then I'm gonna pause while I save this, and then and then we'll see what other stuff I'm supposed to study, because I don't know if you, this is already 15 minutes. Wow. But still, like studying for 50 minutes versus days or weeks for one interview, when you can just kind of ask the LLM, hey, like, what should I cover? And can you design the questions so that I'm sure I'm covering everything? Right? It just seems like such a smarter design. And if I was really, I mean, I feel like probably 10 interviews, getting a job offer out of 10 interviews is, I think, like very good hit rate considering the amount of competition right now, because there's so many layoffs in from bigger companies. Although I do have like serious advantages because I've gotten to work at startups and bigger companies on the business intelligence stuff too. Like that's a huge plus. I have my own set of clients that I learn a lot of business intelligence type skills from. And then also the complete full stack. So from literally web development all the way through computer science, through data science, through now like generative AI, like that's like a pretty sick skill set. And then also the image and video generation skill set that I got to perfect at one of the big companies that I worked at. Right. So I'm not worried about that as much. I think it's more going to be like a, what is it called? Culture fit for myself as well as them. So that's one of the things that I practiced with Tesseraia was, how do I bring up the question of, I'm in the business of automation, which doesn't sit well with people whose jobs are being automated, understandably. And I was asking him, how do I professionally say, hey, like, what responsibility are you going to take if you're putting me on a team where I'm going to be automating what they're doing? Because you never know what kind, like what you're getting thrown into, or into a new team where we're going to go around automating people's jobs. Because I've been through both of those things, and I mean, emotionally, it's really difficult to be put in that position and to manage it on your own. So it takes a certain personality, and like I'm really proud of what I do, and I think it is a service to humanity to let AI do the stuff that will let us use our brains more. People are scared that AI is gonna like make us all dumb. I think not using AI and letting people shuffle papers instead of having to learn something new, but probably is this because I'm a former teacher. I think that is a bigger disservice. Like I think it's a bigger service to humanity to push people to having to learn how to think in a new way. Plus the AI plus human collaboration is just phenomenal. It's like the outcomes are just phenomenal. Then right now there's not a way that the AI by itself or that the human by themselves could get to these points. I think when there's ASI, it'll surpass us completely, but it still won't be able to. I can't say that it won't, actually. I can't even claim that. It might even be more creative than we could ever imagine, and in a way it has to be. But now I'm going into like some philosophical crap, and I should really be studying for this. So I get back on this, and I'm gonna pause this. It's already 54 minutes. But like I said, it's like it's nothing compared to well, to the income. I mean, I'm not gonna lie, like, but that's why I picked this because first, before picking a career again, because this is like, I don't know, my 10th career. This time I actually researched like what is actually gonna like help me have a better quality of life, and what's gonna stand the test of time. And AI wasn't even a thing when I applied, at least not in the public domain, not in any of the places I looked up. But it's certainly divinely, like, I'm not going to say anointed because that's a very big word, but I am definitely divinely led. I have definitely been blessed by the divine themselves, I feel. And my social circles like have continued to encourage and bless me, and like on this path. And bless is like also a very strong word, so I guess like um encouraged me on this path and supported me on this path. But I still, like, clearly you're seeing, like, I'm still putting in the work. It's already 9:42 p.m. and I'm still here studying, right? Instead of getting to watch TV or whatever. But this is more interesting to me anyway. Like, I would rather build the stuff that's on the TV than just sit there and watch it. So I will admit, I've frequently been sucked into the addictive YouTube content because they're just such good creators on there. Anyhow, pause. Okay, so yeah, I have to like look over all these, like, the camera. Am I the only one that feels like the camera's always like right in the way of looking like you're looking at the camera? Um, so now let's ask Tessariah what other questions we need to study for. Okay, Tessariah, what other technical topics should we cover?
Let's take a quick inventory of what we've covered so far and identify the gaps. What we've covered: 1. Fine-tuning LLMs, SFT, supervised fine-tuning, and RLHF, reinforcement learning with human feedback. Runtime generation parameters, top K, top P, temperature. 2. Retrieval-Augmented Generation, Preprocessing, TF-IDF, Cosine, Similarity, K-means, vector databases. Embedding retrieval versus generation pipelines. 3. Precision versus hallucination, reducing hallucination through data clustering and dynamic querying. 4. Difference between BERT and GPT, retrieval BERT versus generation GPT. Topics we could cover: model performance and benchmarking, metrics to evaluate LLMs, Blue, Perplexity, Recall, etc. How to monitor accuracy, latency, and robustness in production. 2. Data quality testing, tools and techniques for validating input data, automating data validation, e.g. PyTest, custom scripts. RAG pipeline design, how to balance retrieval versus generation in a production pipeline, handling edge cases when queries don't match embeddings. Cloud infrastructure for LLMs, using AWS GCP for deploying pipelines. Distributed computing considerations for large-scale inference. 5. Ethical AI and data privacy, differential privacy and anonymization in ML pipelines, compliance with regulations like GDPR and CCPA. Where would you like to start? Or is there another topic you want to prioritize?
What was the second one that you said? Because I think that one is the one we haven't covered as much yet. I think it was in the benchmarking one.
Got it. Let's dive into model performance and benchmarking, which includes key metrics to evaluate LLM performance. 1. Bilingual evaluation understudy, measures how closely the model.
Okay, hold on, Tessariah. I'm gonna stop this video because it's already 58 minutes. So I'm gonna make the next video where we dive into these other topics that should go a lot faster than this one, because I think this one was the more like technically dense one. And I'm gonna upload the video that we just finished so that it's easier to upload to YouTube. Yeah. So thanks everyone for watching. So now part 2.